Since day one, we set out to significantly improve the lives of as many people as possible. And with a little help, you found new answers, discovered new places. The right words came at just the right time. And we even learned how to spell the word Epicurean.
R-I-A-N.
Life got a little easier. Our photos got a little better. And we got closer to a world where we all belong.
All stations ready to resume count. 3, 2, 1. We have liftoff.
So as we stand on the cusp of a new era, new breakthroughs in AI will reimagine the ways we can help. We will have the chance to improve the lives of billions of people. We will give businesses the opportunity to thrive and grow. And help society answer the toughest questions we have to face. Now, we don't take this for granted. So while our ambition is bold, our approach will always be responsible. Because our goal is to make AI helpful for everyone.
Okay, good afternoon, everyone, and welcome to Virtual Gen AI Live. My name is Prashant Dagar, and I am a customer engineering leader handling the data analytics and AI ML specialty here at Google Cloud India. So in next 25 minutes or so, I'm going to talk about what you can do with your generative AI solutions and problems using the capabilities of Google Cloud. So in this session, I'm going to take you through all the features and the platform capabilities, right from infrastructure to the Vertex AI platform to all the applications which we have created for you to make it really simple to consume generative AI within your organization. So Google has been using AI for several years now, in fact, decades, right? Many of these features and services which you see on screen, Google Lens, Google Maps, Google Pixel, YouTube, you have been consuming these services to make things simpler in your life, right? And we at Google, we feel the application of AI broadly into three areas. When you start seeing these capabilities and features, they apply to these three areas of personal use, societal use, and for use in businesses and organizations. Right. Some of the examples which you see here, like the magic eraser, I can just use it to remove the unwanted objects and images from a larger image which I have on my phone. Similarly, Google Maps, people have been using it for finding ways, and it uses AI extensively behind the covers to tell you about optimized routes. In case there are obstructions on your current route, then it may also suggest an alternate route using the AI algorithms. Similarly, YouTube, if you think of the impact to the society, if you have used auto captioning on videos in YouTube, for imagine a person who is not able to hear clearly or partially, they would like to understand what's going on a video, right? So auto captioning uses AI to actually help those people understand what's going on in a video. So the simple aim at Google Cloud is to make AI helpful for everyone, helpful in creating the content, new content you would like to create using generative AI, using generative AI to synthesize and organize the information and the data within your organization and to use it much more effectively, to automate your business processes within an organization so that it becomes really streamlined, And finally, to engage customers in a much more efficient way, giving them a next level of experience. So these are some of the broad use cases which we can help you build around generative AI. Now, what goes behind in enabling you to build upon these use cases is this integrated technology stack. So, this is really important for giving you the capabilities to build your solutions using generative AI. Let's start from the bottom. The bottommost part here is the ultra scale AI infrastructure. This is the backbone of this entire technology stack. On top of this, you will see the foundational models, right? These are the models, the LLMs which we have built, which we have trained for you. We do have capabilities in this platform where you can use open source models and the third party LLMs as well. And I'll talk about those as we move forward. And then we have our end to end AI and ML platform. We call it as Vertex AI, which you can actually use to build your own generative AI capabilities, to fine tune your models, to play around with your models, to use it in a form of API and embed those within your applications, and many other experimentations which you can do around generative AI using this platform. And then on top we have Duet AI, which is like a AI collaborator sitting beside with you. We have Duet AI for Workspace, which helps you write documents, helps you create slides, helps you write email, summarize content within these services and so on. And then we have Duet AI for Google Cloud, which is like, we call it as a customer engineering sitting beside you from Google Cloud, who can help you understand the best practices on Google Cloud, help you spin a GKE cluster, help you tune your BigQuery and other databases, summarize your logs, and so on. And Duet AI for developers is something which we have released today. It can be used to write new code, to review the code, create test cases, and do anything developers do on a day-to-day basis. So this is the entire stack which we are going to learn today on how this actually helps you build your generative AI applications. So let's start with the ultra scale AI infrastructure and the platform on top of it, which is the Vertex AI, right? So we call this infrastructure as a AI hypercomputer. It's the next generation supercomputing architecture, predominantly suited for machine learning and AI. It has three key pillars. Starting from the bottom is the performance optimized hardware. These are the performance optimized compute, storage, and networking layers, which are stitched together to provide you in a hardware which is suitable for any type of machine learning jobs. So things like GPUs and TPUs are part of the compute. You might already be using vCPUs, and other formats of compute in the Google Cloud platform. But if we speak of high performance computing, then NVIDIA GPUs and our own proprietary TPUs are much more, price performant as compared to the normal compute infrastructure. In the middle, we have the open software stack. So all the famous ML frameworks like JAX, TensorFlow, PyTorch are provided out of the box. You can use the multi-slice training and multi-host inferences, the TPU multi-slice trainings for doing parallel processing and providing you an optimized performance. The XLA compiler for your advanced linear algebra and all those things. And then you might have heard about Kubernetes engine and the compute engine, which people are already using while building their applications today. So these are now very well integrated with this entire generative AI framework as well. And then on the top, we have a flexible consumption model. Some of these things are very new, like the dynamic workload scheduler, which is very well tuned for the machine learning ecosystem. So there were spot frameworks available earlier, but with this dynamic workload scheduler, you can actually allocate and use the high performance computing infrastructure like GPUs and TPUs much more efficiently, both in terms of performance as well as in terms of price. For example, I can actually schedule a job to be run on so and so date for 2 hours, and then allocate few TPUs or GPUs to it, and so on, and it gets based on the availability, it gets kicked on as and when according to your calendar, which you have already scheduled. So these are some examples which we have introduced new to actually make your life very simple when you're trying to build generative AI applications. Okay, since we are speaking of infrastructure, one of the key announcements which we made, I think, in August, is around a new version of TPU which we have introduced. So those of you who don't know, TPU is our proprietary hardware, which we the kind of data which Google handles at scale and does machine learning, it is much more price performant as compared to other high performance computing resources available in the market. If you take, for instance, TPU version 5e, it is 2x advanced in terms of performance per dollar as compared to the previous version, which was TPU version 4. And same is the case with in the performance per dollar of inference, which is 2.7x as compared to TPU version 4. Right. So these are the kind of benefits which we are passing to the consumers of this platform once you start using TPU version 5e. Okay. The next layer on top of the infrastructure is the foundation models. So, what you see on the screen right now, these were the 6 foundation models available till some time back, till 5th of December. So, we had PAM for chat, PAM for text, ImageGen to create images from text, Chirp to create, speech to text, and then we had the embedding models and Cody to help our developers. But December 6th, we announced a new set of LLMs, foundation models, which is called as Gemini. So I welcome you all to this Gemini era. It's a it's a it's a set of models which provide you the multi-modal capability, meaning using this single model you can actually do text, you can do code, audio, video, images, everything. It is available in 3 sizes as of now: Nano, Pro, and Ultra. That's what we plan. Nano would be for smaller devices like watches and mobile phone. It would be available on Pixel 8 Pro. Then we have the Gemini Pro, which is which would which is running behind Bard now. It has replaced the Palm model, and from yesterday, it is also available within the Vertex AI platform. So you can start experimenting and creating your application using the Gemini Pro. And Gemini Ultra, it's some time away. We would be releasing it soon. So this is actually the next level of generative AI LLM models which we have introduced, and we would be doing some demos around the Vertex AI platform and how you can actually consume these LLMs and so on once we move to the next session. Okay, now let's try to do a double click on what is Vertex AI. Right, we spoke about the infrastructure and the foundation models and the Gemini which would be available, but how do you start consuming it, and what are some of the services in this entire platform and ecosystem which are available for you to make these LLMs suitable to your organization, right? So starting from the bottom, we have something known as Model Garden, right? So Model Garden is like a single repository of all your models, be it Google Foundation models like Gemini, Pro, ImageGen, MedPalm, and so on. These could be open source model like Mistral, ImageBind, Ito, Llama, and so on. and even third party models which could be solving a specific problem for a specific industry. So as of today, there are around 130 models available on the Model Garden. So it is a single place from where you can actually uh, deploy these models and start inferencing it, putting it on an edge, and so on. This is a screenshot of the actual Model Garden, and you can see, Gemini Pro available here as of yesterday. So you can even play around with this. And Gemini Ultra, like I said, would be available in private preview to selected customers, and then gradually we would be GAing that as well. Another announcement which we made was, you might have already used image gen model. So now we have image gen 2, which gives, it's actually an enhanced version of image gen, and the kind of images which you see here are much more photorealistic as compared to the previous version. So there are those gradual improvements which are being made as we launch these new versions. And then you can actually do text rendering, create your own logos on top of these images on the products which your organization is launching, and so on. So a lot of capabilities have been added in image gen 2 model. Okay, now these models are available as part of the Model Garden, and you can do a lot of things around these models using Vertex AI. But to make these models usable, to make sure that the information which you are getting out of these models is not a hallucination, there are certain knobs and features which we provide, right? So first of all, you are able to tune these model based on your requirement, your organization's data, using multiple ways, like you can do prompt designing and fine tuning and adapter tuning. We also have now RLHF available within the console. If you want to do a reinforcement learning from human feedback, you can provide a JSON file with the way you would like to see the output, and you will see the model giving the output in a particular way, right? So all these features are now available within the Vertex AI platform to help you tune and customize these models according to your requirement. Some of the other things which we have introduced are features like grounding, right? So you have a model and it's giving you some output. I think I have an example on the next slide. Yeah, let's take this example. So somebody writes a prompt, explain my employee provident fund contribution limit. So without grounding, a model would give a very generic output like, for 2023, you can contribute up to 12% of a basic salary, and there might be some other information which this model might output. But what I mean by grounding it, you can actually link it to your enterprise information. And when the data comes, it would be very specific to you. It would be very specific to your organization. So based on your income, the link to the HRMS data which we have created using the various extensions which we have, you can actually get an exact answer of that X is the amount of contribution which you can make, and so on. So this is actually the private data which now you can access from by using this grounding service, and you don't have to do anything additional or write any API or code for this. This is out of the box. There are other features as well, like I mentioned, connecting your models, your applications to your other sources. For example, my HRMS data, or it could be if I am having a chatbot which is answering question on my tickets, then I can create extensions to Jira. Some of these extensions are already readily available, and we are adding more and more. But we also have a capability in which if there is a source to which you would like to create an extension, then you can do that. So this completes the entire workflow journey of a generative AI solution, having an extension. Similarly, you can have functions if you want to take further action on the output which is being generated by a model. There is a capability of orchestration. So let's say if you are using a Gemini Nano on a phone and you would like to fall back on a larger model, Pro or Ultra, for a particular scenario, then that can be done using the orchestration capabilities. Okay, you have models there, you have created your own models, fine-tuned them and so on, but how do you evaluate that whatever you're getting out of those models, how's the latency, how are some of the other matrices which you would want to evaluate your model on, right? So we do provide automated evaluation metrics. It could be for a single model, or you can compare two models. You can throw the prompt at both, and then it's like A/B testing, which you can do using this evaluation metrics, right? Then there is a complete governance framework around these models. Who used for what purpose? What was the prompt given? How many accesses were made, and so on, right? So a complete governance framework and registry available for these models as well within that same platform. Okay, there are, when we spoke to the enterprises across the globe, there were two very eminent use cases which emerged out for generative AI. One was search and the other was conversation, right? And we provide these two use cases out of the box within the Vertex AI. We call it as the Vertex AI Studio. So using that, you can actually create both Vertex AI Search and Vertex AI Conversation applications. So how it works is you have a set of input sources, and in between you have a orchestrator layer where you will find all those capabilities which we just spoke of: extensions, grounding, connectors. Because when you are creating a search or a conversation solution, you would like the answers to be grounded. They should be coming from a relevant fact-based information rather than just hallucinations. So you create these extensions and connectors to your sources, and then the output can be consumed in multiple formats. These could be bots, these could be search engines, these could be your application, mobile or web UIs, and so on, right? Or these could be a trigger to a workflow. Let's say somebody is asking to book a ticket, and then it goes into the actual transaction system, does the payment and all those things, and completes the transaction, right? So these are some of the use cases which you can very easily build using the Vertex AI search and conversation capabilities available within the platform. Okay, last on top of this particular framework is the Duet AI. So like I said, it's a AI collaborator which helps you in doing a lot of day-to-day stuff, in automating, helping you around with, let's say, helping you write a code, helping you figure out what would be a suitable schema for my database, helping you write an email, helping you create a slide, create an image into a slide, and so on. So it's a collaborator sitting with anybody in information technology today, and it really helps in shortening the time to your day-to-day work. So here are some examples of the two formats of Duet AI. One is on the top, you see Duet AI for Google Workspace. So it helps you writing emails. It helps you write, let's say, job profiles, your year-end appraisals, and so on. It can help you organize data in sheets, apply formulas, and all those things. Then, like I said, creating beautiful slides, you can use it. There are a lot of use cases of Duet AI in the Meets as well, our communication service. And Duet AI for Google Cloud, it's really interesting. People have been using it in various ways. For example, uh, like one of the examples which you just saw, how can I reduce my Cloud SQL, MySQL database cost, which is actually coming in the Google Cloud platform. So it will take you through some of the best practices on how you can do that and so on, right? How do I write a cloud function, and it can actually help you write a code, creating schemas and so on. So Duet AI for Google Cloud is your answer to any questions which you have around using Google Cloud. Okay, Duet AI for developers, released today again is powered by generative AI. It helps you in completing the code, generating it from scratch, creating my test cases around the code which I am writing, doing operational diagnostics, and so on. And it is free for use from yesterday till February 1st, 2024. So give it a try. I hope you would like it. Okay, now I'm going to touch upon a very important topic when it comes to generative AI. Right. So we spoke of all these models and enterprise data being, used for creating the solutions and so on. So how do we make sure that the solutions which we are building using generative AI is suitable for our enterprise, is completely secure, is completely governed, right? My data is not leaked. How do we make sure? So this is something which we really consider very seriously at Google, and we try to keep your data as secure as possible. Even before generative AI and all these platform integrations were done, there were various controls in Google Cloud Platform which you can use to secure your data, because there were transactional databases of banks which run on Google Cloud. There are immensely critical confidential information which customers keep on Google Cloud. So how do they, what are the various parameters which are available to them to make it secure? What are the various knobs which are available to govern the access to that data at all the levels from A to Z, right? So all those capabilities and features already existed in Google Cloud, have now been integrated with this Gen AI platform as well. So whenever you are putting any data in Google Cloud, it gets encrypted, and you can encrypt that data using customer managed encryption keys. Basically, the keys would be yours. There are VPC service controls, which is like your own private container in which you keep all your data. Access transparency around who is accessing the data, what time, what are they trying to access, and so on. And then the traditional identity and access management permissions, very strongly integrated into all these services. So getting double clicking on this architecture which you see here, it might look complex, but it conveys a very simple meaning. This blue rectangle which you are seeing on top is actually your Google Cloud parameter. Any tuning, adapter tuning which you are doing for a larger foundational model or a LLM remains within your tenancy. It doesn't go into these LLMs. The foundational models which we have are completely frozen. There is no data which flows into these models. That data belongs to you, and it is up to you on whom you are giving permissions for accessing that data using all the controls which we just spoke about. And then you can actually govern and see who is using that data in what format, right? But the access to large foundation model, the data being sent there, that is not a possibility. It is completely locked. That's what we are trying to convey here. So your data remains with you, and you have the sole responsibility of providing access to the data to any particular individual, to your partners, to your third party vendors, and so on. Okay, this is probably the last slide. We have been developing is a very strong, open and innovative partner ecosystem around our AI, be it service partners, SaaS and application partners, technology platforms, open source partners, and foundation model partners. So these are just few names. It's a lot larger than this, and it's growing on day-to-day basis. So you are not alone in this journey. When you're planning to create something using generative AI on Google Cloud Platform, we can provide you help in any possible way. That's all I had for today. Thank you very much. And with this, now I would like to invite Lavi on stage.
All right. I hope I'm audible. Let me share my screen real quick. Okay, while the screen comes up, thank you so much, Prashant. I think that was a wonderful session, and I hope everybody sort of gets the gist of what we have as an enterprise offering and what are all the things that you can do at your end. Very similar to how Google is sort of trying to do with its consumer products across the world. And I hope now you can see my screen. So just a quick intro. This is Lavi Nigam. I work closely with the Vertex AI SDK team. I'm ML engineer by profession, and today what we'll be doing is I'll be walking you through how to sort of play with the API. So we have seen all the different offerings that we have, but what we're going to do is we're going to go over and see how those APIs can be leveraged to sort of build things at your end. Now, one of the things is we have already sent you the lab. This lab is going to be very important to you. You'll have access to it after the session. And there are three labs into it. What we are assuming is, and I'll not go into detail of it, is the fact that you have already done this lab before coming. This will sort of help you if you've already done that, in a sense that there's a lot of things that we'll not be able to cover in 1 hour window. So the first lab is what we'll start with, and this lab will sort of focus on introduction part of the API, but I'll also sort of walk you through the Vertex AI ecosystem and what all do we have in that. So when you click on this, and again, these are all the steps that we have already shared with you, and you should be able to sort of run through things as of now. Is when you start the lab, it sort of gives you. In fact, let me actually do this live so that one last time you can see. So you can start the lab. The moment you start the lab, it'll give you 1 hour, 30 minute, and it'll sort of do the provisioning of the lab resources. The lab that you're trying to look into currently is the getting started one. It has a couple of steps, which we are again assuming that you have gone through and you have covered and followed all the steps. So all the steps that I'm going to show you are essentially the same steps that you'll see here. So once you do that, you can simply open a new Cloud Shell, and it automatically copies your username. You can just copy the password. Now, why is this important? Is because we are going to use some of the services which are paid. So you would need a billing account to sort of use those. And that's why we are giving you access to a dummy account, an account where all the setup has already been there. So we'll just do a quick agree and continue, and you can see that we are on the Google Cloud Console. I've already sort of increased the font size and sort of resolution, so things sort of looks more crammed up. Now there are a lot of things in the cloud console, but our focus today is Vertex AI. So I'm going to search on the top, and I'm going to click on Vertex AI. Once you come here, you'll see again a lot of things going on here. But let me sort of walk you through some of the basic things, and then we'll sort of jump to the lab right away. So on the left hand side, you will see Vertex AI Studio. So this used to be called as Generative AI Studio, but we yesterday we changed the name, and now the name is Vertex AI Studio. It has language, multimodal. So multimodal is the Gemini model. So this is where you can actually see how to sort of play with Gemini. Just to show you one example, let's say if I open this up, and this is where you pass a simple image, so you can actually insert your own images. It tells you what kind of images you can pass. It also tells you the kind of extensions it is expecting, so you can check that we expect you to pass a png or a jpeg, and if you're passing a video, what is the length and the size of that should be. And you can simply see, read the text in the image, and then you can submit. On the right, you will notice that I'm using Gemini Pro Vision. There are two versions of the model, and you can see it actually gave me a response. The best dreams happen when you awake. So this is what was written in the text. And there are two models. One is Gemini Pro, which is a text-based model. So that model sort of only takes the text and then produces a text, very similar to the Palm model that we play with today. The Pro Vision essentially can take text along with images and video, and we do have examples of it for you to play with. So feel free to sort of go and play with this. There is an example of video as well, so I would leave you to it to sort of explore and see how all the things function there. Going to the language part, this is where you'll see specific language input, language output things, including the code. So if you notice here, you have text prompt, code prompt, and then the chat model. So, and we'll see the same in the API as well, that there is a difference between one-on-one prompting, which is more or less what we typically refer to as one-turn conversation, where you put something and then you expect the output. You don't carry forward that conversation, or you're not expecting it to sort of do a chat conversation. And that's what you can do in the chat side of things. So if your goal and your aim to build an application which is more conversation driven, something like Bard or Chat GPT or anything like that, then you prefer going in the other direction, which is chat. If you're more sort of one-off translations, if you're trying to do that, you would go in the one turn. What I'm going to do is, and again, this distinction is important because in the API you will have very similar distinctions as well. So you'll have an API for text bison and you'll have API for chat bison, and both of them will be different. If I come down, let me show you sort of a couple of examples. So let's say we open this one. What this shows you is how to do a summarization. So if you notice, you can actually put an audio prompt as well. This is not processed by model as is, but it sort of uses cloud speech to text to translate what you just said. And you can put a prompt, and this is a nice UI where you can sort of experiment with things before you move on to the code side of things. So you can see that we are sort of putting up a prompt, which is you're a financial analyst and you're required to summarize the key insight of a given numerical table. This again assumes that you already have this table. And on the right, again, you can notice that we do have Gemini Pro. Like I said, Gemini Pro is not multimodal. Gemini Pro is just text input, text output. Gemini Pro Vision is multimodal. But here on the right, you will notice that we do have many other kinds of models. So we have Text Bison, which is our focus today. But Text Bison also has many different variations. So Text Bison latest is the latest model we keep sort of pushing. So that's not stable, but that's one of the latest and the best that we have been working internally. The one that you have is Text Bison 32K. 32K here refers to the input token size which the model can expect. So 32K essentially means that you can send more and more as part of your prompt. And again, we'll see that. And then the latest GA version that we recently launched is a 002 version, which is what you can notice with the @002. The older one, which is the 001, and we'll most of the API that we do today will be around 001, will also be there, which is the best value and sort of slightly cheaper. And like this, you would have models. So you also have models for code generation. So the code generation model inside the Palm family is called Code Bison. So you can see the clear differentiation between the naming, right? So the text is more like input a text, output a text. Code Bison is more like you input a code and something that you're trying to do, and then it gives you the code back. Again, same versioning and the input token things are given here. So you also have a 32K version. You also have @002 and 001. Like this, you have sort of multiple models which you can select from here. You can also sort of change certain parameters. These parameters sort of affect the model in a sense that the outputs will be changed as per what you set here. Temperature being one of the most important one, which controls the creativity or the deterministic aspect of your output. So if you're looking for more deterministic, more sort of human like or real life kind of an output, you keep your temperatures towards the zero side. And there are slightly less chances of hallucination because it's sort of trying to make sure that everything is coherent. It doesn't use many fancy words or things like that. If you put it towards one, let's say towards the one side, then you're expecting it to give more creative, more new words that you may not expect in that sense. And then you can also sort of select the token limits. If you're trying to sort of not generate too many words, you can select the token limit with that sense. So the model that we're using is Gemini Pro. Gemini Pro, as you can see, is expecting 8192 tokens, and this is the limit that you have. And like this, there are a lot of advanced parameters as well, but we'll not sort of go into detail of that. And I can simply do a submit, and I'll just wait for it to give me back the answer. So Gemini Pro essentially gives the response in a streaming way. So if you notice that it came step by step, like it was sort of generating element by element. So it does support streaming by default. So you'll be able to sort of get output by that. And you can change that. So I can go up and I can go to text Bison, let's say 002, or actually text Bison 002, which is the recently launched. And you will see that this is not, it does has a streaming component, but we are sort of using the non-streaming component as well here. So we'll wait for it, and you can see that this is where you'll get the output, and it sort of figures out whatever you've been asking it to do. So again, the reason UI is important for you is because you can sort of do a lot of experiments and prototyping in the UI, and then this is where you can move back to the API to sort of do things which are different. You can also do a bunch of other things. For example, you can do extraction of information from the text. One of the things which I want to show you is that every time you do any experiment, on the top right, you will see something like get code. So the moment you click on this, you actually get different kinds of codes which are available for the same prompt that you've written. So you can directly export all of this without the worry of rewriting or copy pasting any of the other prompts and things. And it gives you the whole code along with what is that you need to follow along to make it work, let's say in Python. We also give you Node.js, Java, and finally the one which can be used across many other languages, which is the curl command, how to get that. So it supports all of these, and this will be very easy because once you're done with prototyping or experiment, you would prefer moving to your API environment in that sense. So let's run this. Oops, I don't want to do this. I want to select, let's say, text Python 002. And this will again do extraction. And we have asked it to sort of go through the whole process and extract certain things out of it. So that's what we have from a text Python perspective. Again, there's a lot of examples. I would again leave you to experiment and play with this. It shows you many different kinds of things so that you can sort of focus on those parts. So one of the examples that I want to show you is, let's see if I have any chat examples. Okay, so this is how the chart essentially looks like. So if you select again chat Bison 002, one of the things that you can do, and I think maybe I can sort of reduce the size just to show you this, is the fact that chat essentially has a context, which is a system prompt. If you have seen other LLMs, you know that you can actually send the system prompt to the functions. And we'll see in the API as well that you can actually send as a context. So context here sort of refers to the fact that if there's any preamble or priming of the chatbot, or let's say the chat interface that you need to do, for example, you want the chatbot to, or let's say this model to always respond with a name Bart, for example, let's say that's what you want to do. So you would put that as a context, or let's say all the information and all the responses it needs to generate should be generated with, let's say, some context of a text which is coming from your documents. You can sort of put all of this here, and then you can start doing the conversations with it. Again, it has the same amount of parameters, selections of models. The models are different, as you saw that we were doing the text Bison before, and now we are doing the chat Bison. This again comes with the get code. So when you go to the get code, you can actually see in Python how to sort of do the same thing. And again, we'll sort of spend more time going to the code side of things. The code prompt is again same, so there's nothing that changes there. The code prompt here essentially means that now it is expecting you to sort of put queries which are more focused on code generation, completion, or let's say you're trying to generate a documentation, doc string, you're trying to create type hints into your functions or anything around that. This is where you can sort of do all of those things. One point to note here, which is very important, is that you can actually generate code using the text prompt, which is using the text Python model. So it's not like there's some limitation and the normal text models cannot generate code. The difference only here is that the Cody models or the code models specifically, which are tagged in the UI, they are built or they are optimized to give you better responses when you're doing some complex code generation. So that's why there's a difference between Cody and text. So do remember that you can still generate code with text Bison models, but the model which is Cody is highly optimized and retrained with the code keeping in mind. And there are a lot of different languages which are being supported here. So that's a quick sort of UI overview. You can save your prompts. So all the prompts are saved here. Google doesn't use any of your prompts, as Prashant was pointing out. We do not use it for training. We do not send it. We do not share it. So there's nothing that we do with your prompt. So you sort of save the prompt as you wish. In fact, you can sort of tune your models. This is not again part of the things that we'll try to cover today, but the fact is, just with the UI, if your data is ready to be tuned and there's a specific format that you need to send, you can actually tune the model, and you can also sort of create a distilled model which is doing the teacher training and things around that. So all of that can be handled from both UI as well as the code. So both of them are available. Feel free to sort of explore this, go into more details, and again, keeping in mind that we have a 1 hour session. What I'm going to do is I'm going to jump directly to the hands-on. I mean, we were doing the hands-on, but we'll jump to the API part of things. So to do that, what you need to do is you need to go on the left, and there's a workbench written there, in which you will go to the user managed notebooks, and let's see if this opens. All right, perfect. So this opens, and then what it shows you is a Jupyter lab which is already being provisioned for you. So the moment you actually started the lab, this lab was initialized automatically for you. And what this does is, while this is sort of playing out, let me sort of show you what it is doing in the back. And this is again an open source repository that we have. This is cloning the generative AI repo. This is a repo which is there on the Google Cloud Platform GitHub page. In fact, I would sort of just show you that you can just search for generative AI Google Cloud Platform and you'll be able to get the link of this. So all that is happening is essentially this whole repo gets cloned in the environment, so that we can then go through each and every. I mean, you can go through each and every notebook, but we'll sort of focus on one of the notebooks. We recently launched the Gemini notebooks for it. So if you want to really see how to do all the multimodal things and all the text things and everything around that, and how do you do this from a Python perspective, feel free to sort of go and explore all these notebooks. So when I now go to the Jupyter Lab, you'll see that this is exactly the same folder that gets cloned in the environment. So you can notice, in fact, let me sort of increase the size. So you can see generative AI gets cloned, and you can see it also has the Gemini notebooks, and you can just go to getting started. And we have a bunch of notebooks, starting from the very basic to the very advanced, which is how do you, for example, do multimodal track, right? So a lot of you, if some of you have heard about the LLM things, you know that retrieval augmented generation is one of the very important grounding methodologies in the LLM. So we have given some of the labs where some of the notebooks where you can actually explore how to do that same for the multimodal cases. It has function calling, it has a bunch of other use cases, but again, these are something open for you to explore. You have the lab with you. Feel free to sort of go and run all of those things. What we are going to do is we're going to go to language, because again, like I said, our focus is to learn how to do text Bison and chat Bison and code Bison. So we'll go there. We'll directly go to getting started, and then this is the lab. So this is the same lab that if you have completed this lab that we have asked you to, you should be already familiar with what we are going to do right now. So if I go back, this is the lab we need, which is intro palm API, and I'm gonna close this up. And this is the part where we'll sort of try to understand how to do exactly what I just showed you in the UI, but from a Python SDK perspective. And I've already sort of explained this to you that you would sort of start the journey through the prototyping and experiment in the UI. And then when you're ready to sort of put this into production or maybe connect this with your databases and other integration points, you would then sort of explore the API endpoints and all of this. And this is a Python example. You can actually use this in Java, Node.js, and through curl in the other web interfaces as well. So let's come down and we're going to run a couple of things. So let me install Google Cloud AI Platform. So this is the SDK that you need to access either Gemini or Palm models. So this is important. The latest version is 1.38. This is sort of sticking to a specific version for the to make sure that there's nothing that breaks away. But you can actually just remove it and get the latest version, which has the Gemini endpoints as well. So you'll do Google Cloud AI Platform, which is the SDK through which you're accessing the model. And once this is done, Now we have given you steps. So there are steps which are collab specific, and there are steps which are Jupyter notebooks on Workbench specific. So if you would want to run this notebook on Collab, there are certain authentication that you need to do, because again, do remember, this is not an open API. This API is sitting behind the Google Cloud authorizations, which means once you have a billing account, you'll be able to access this all. And hence you need to do all of these authentication. As you can see that if you were to run this in the Collab, you would have uncommented this, done the authentication, and then passed your project ID. So you can see that this is again a Collab specific step. So we are not doing it because we are doing the Jupyter notebook inside the Google cloud ecosystem. So it already knows all of this on behalf. But if you do this on Collab, you would actually pass your project ID. Project ID is nothing but, if you go back to console on the top, you will see this, and this is the ID that it is expecting. So you would need to pass that so that it knows that, oh, this is an account, and this belongs to this person, and it already has billing enabled because we're using paid components, right? Okay, so what we're going to do is we're going to import some of the functions, some of the classes and the methods that we're going to use. So first is text generation model and text embedding model, and we'll sort of go step by step and we'll sort of talk about it. It is absolutely fine. You'll see some of the values and all. That's fine. You can sort of ignore it. You shouldn't worry about it. Once this is loaded, let's start with the first point, which is where you establish your connection with the models. So this is where you're essentially loading the model. What you're doing here is you're using the class text generation, and you're calling the function or the method of that class, which is from pre-train. And then you're mentioning the name of the model. And hence I was showing you that each and every model naming is very important, because even when you do this from an API perspective, you would have to sort of mention the text bison at the rate 001. The other, other thing which is important is this is where you can mention 002. This is where if you do not mention anything, it is going to take the latest one, or you can explicitly mention at the rate latest, right? So all of this changes has to be done at this stage. So we'll keep it 2001 because that's the one that we are exploring right now. The other thing which is important is to know that this doesn't downloads the model to your sort of Google Cloud tenant, right? And this is important because what you're doing here is you're establishing a RPC call, or let's say the REST API connection with the model which has been copied to your tenant. So it's important because sometimes people say, oh, can I download this model at my laptop, or can I do this offline or something like that? So you'll not be able to do this offline. Every time you hit the model, you're basically doing a simple REST call, which means you need to be connected to the internet to do any of these things that we are doing. So that's very important. All the model functions this way. And secondly, the reason you cannot download is because this is not an open source model. If you want to explore open source models, like Prashant has shown you, you can actually go to Model Garden. So in the UI on the left, you will see something called as Model Garden. In the Model Garden, you will see many of the open source models like Llama, stable diffusions, and things like that. So that is, if that's your use case and that's what you want to do, you basically then shift to Model Garden. Model Garden again has all the notebooks and everything given there, so you can sort of explore. But if you're trying to use Google trained, pre-trained model, either Gemini or Palm or anything, then this is the method for you to do this. Or you go to the AI Studio to select those models. So AI Studio currently doesn't let you load the open source model. So there you can only use the text bison, which is the Palm family model, as well as the Gemini models, which is the Gemini models. So once we have the model initialized, so you can see that we now have the object generation model. We can now simply send prompts to it, right? So the next one is I'm sort of putting up a simple prompt saying what is a large language model, and I'm using the method which is generation model dot predict, and we are passing the prompt to it, right? Again, very simple. There's nothing complication. There's nothing fancy here. Once it gives you a response, you're then checking the response.text. So response.text essentially sort of stores the actual text that you have. The object actually returns many of the other things. So it also returns safety attributes, safety ratings, and all of those things as well. those becomes very important if you're trying to, let's say, for some reason moderate the responses of the API, so that you make sure that people don't send weird things to your models, and they're also sort of not getting weird things out of the model, if you want to sort of have that kind of a control. But we are only accessing the text component because at this point we're sort of focusing and going step by step. So this is where what you can do is we have given you some of the other prompts as well. So feel free to sort of change the prompt, play with it, maybe try sending something a bit more specific prompt, or try asking some kind of an extraction, summarization, or something of that sort, right? If you're not sure of what examples to sort of use or play with, what I would request is you again go back to the UI. In the UI of Vertex AI Studio, there are many samples which are given here, right? So you can notice that there are many samples given here. So from here, you can copy those prompts, and then you can go towards the notebook, and then you can just paste this and then run this from an API perspective. So you can do this back and forth. If let's say you're not clear with what is that I need to do, like what kind of prompts I can do and things like that, more on that. So there are many more places. We also have notebooks which sort of explores or gives you more details of the prompt as well. So once we have done that, here's another prompt which is sort of slightly more specific and slightly more we're trying to ask more specific things there. So we're saying create a number list of 10 items. Each item in the list should be a trend in the tech industry. Each trend should be less than 5 words. So you can see that we are essentially sort of putting a lot of instructions in the prompt now. And this is a standard word that you'll see with the prompts as well, which is prompt has instructions and model has capability to understand those instructions. So in this case, we are saying I need 10 item list. Each list should be less than 5 words. So you can see that it actually followed your instruction, and it sort of kept this in mind that, oh, I need to have 10 and each should not go beyond 5 words. So it kept itself to it. So there is, and this is one very important thing that needs to be understood, which is each model has two ways of control. One is through the instructions which you provide in the prompt, and then the other is through the parameters that you have in the model. So again, we saw this in the case of UI as well, that every time you're writing a prompt, on the right you have some controls or some functions that you can change. So both of this put together affects a lot of things that comes as an output, right? So always remember, and this is something that we have observed often with a lot of people and a lot of developers, is the fact that they will just write very non-coherent prompts, and then you basically get stuck because you're not getting the output, right? So the suggestion that we give to them is that try adding more and more instructions, because these models are very good at following those instructions. So be very specific that I need this, the output should be like this, it should have a dictionary, it should have a list, it should have a table, whatever that you're sort of focusing on. And then even in that case, you can then also sort of try to tune or control the values which are there in the parameters, and that will have a slightly more effect onto this one. So that's the bit about this. The other thing is you can also sort of use prompt templates. Prompt templates are a way for you to sort of pass anything dynamic. So let's say the same prompt that we were using before. This time, I don't want the tech trend. I want, let's say, the marketing trend, or I want the sales trend. So you can actually just do a simple prompt template. This is very non-trivial because you're essentially using F strings here. So it's not something fancy that the model is doing. It's like, as a developer, you can sort of do these things, and this is how sort of you can create more extensive applications and use cases around it. So let's try to do this. You have again the same thing, and we can actually try giving marketing here. Let's say if it does that, perfect. So you can see that it gave us the same thing, but this time it's for the marketing. One of the other thing that you will notice is, and the reason I was using the 001 model is that it is now very fast, because again, it's a smaller model. There's a whole set of model sizes that we have, but 001 is a very small, and it's very mature at this point. So the results are very fast compared to the other models. So you'll see the latency differences between different models, because they have different maturity cycles, and they take time to sort of mature and give you faster responses. But you can see that how fast this is, right? Now let's see some of the temperatures and how do you pass those temperatures. There's a lot of theory behind it. There's a lot that you need to keep in mind, but I'll try to simplify that. And again, every markdown is given here. You can spend time reading through it, trying to sort of understand what are the nuances behind these values. But what we can sort of understand at this point is that temperature is something which controls the sampling of the words which are being used, which means if you're looking for more creative kind of output, something which may not look very real, it doesn't mean hallucination, right? So one very important point to remember is that hallucination is a property. It's not something which is inherently bad. What I mean by that is if you're trying to, let's say, write a short story, or if you're trying to write a marketing campaign, you want the creativity of the model to be there, right? So in a way, it will hallucinate in that case, but you're okay with that hallucination because hallucination is the required property when you're doing that generation. It may not be a required property when you're trying to ask a very fact based question. So if you're saying that, hey, I want to know, let's say, what's the recipe of XYZ. You want it to be very deterministic. It should not use any random things in the recipe and things like that. So you will then reduce your temperature towards towards zero, so that you are on the lower temperature, and your outputs and the choice and the sampling of the words or the tokens are sort of in the context, and it sort of reduces every non-deterministic output in that sense. So okay, very simply, if you're looking for more creative output for any creative use cases, maybe move your temperatures towards 1. If you're looking for more deterministic, move your temperatures towards 0. How do you pass a temperature? It's very simple. In the same model.predict function, sorry, the method calling that we were using before, you can actually pass the parameter temperature. And what we are doing here is we are sort of we have a simple prompt which is complete the sentence, and then we are using different temperature value just to show you that how sort of things change. Sometimes it may actually be same, sometimes it may actually differ, but you can now sort of see how you can pass the temperature if you wish to. One very interesting example that we have seen customers using is, let's say, you're a company which is generating, let's say, captions and tags for users. you, your consumer doesn't need to know these temperature things. What they can see at their end is that, hey, do you want more creative captions, or do you want more normal sounding captions? So if let's say the consumer selects, I want creative, then in the back end you can set the temperature at zero point 0.9 or something much higher. If the consumer selects, no, I want something normal, I don't want anything creative or something not out of the order, then you know that in the back end you need to set the temperature towards the lower value. Now, this is just one example. There's a lot of things that you can do with the difference in temperature. It sort of also helps you reduce some kinds of hallucinations if you're trying to do more fact based or more reference based question answering. So that's the bit about temperature, and this is how you would pass. And I'm running both with zero temperature and one temperature, and then you can sort of see how in the zero one it stopped just by answering the question that we asked. When we do temperature one, you can see that it didn't stop there. In fact, it gave a new word. So in the previous one, it gave hammer as the output. In the next one, it gave screwdriver, and it sort of also again started giving you more context around it. So it became more chatty in a way. Again, it's not a chat, but you can imagine that it's sort of trying to sort of over explain the things. So that's the difference between zero to one. Like that's the journey that goes from zero to one. The next parameter is the maxed output token, which is again, like I said, what you need to remember is that max output token, and token as a word is very confusing to a lot of people. But one thing, and every model has a very different mathematics to compare it to number of words. For palm models, one thing that you can keep in mind is 100 tokens corresponds to roughly 60 to 80 words. This is very important because then you can sort of do a simple mathematics that, okay, if my limit of the model is 8,000 tokens or 32,000 tokens or 1,024 tokens, I can sort of use the same mathematics to know what is the limit of words I can send into it. So that's what we have mentioned here. So you can do that rough calculation in your mind. In Gemini, we do actually have a simple library that actually gives you the token count Just like you can do this with OpenAI as well. So in the Gemini world, you have it easy. You can sort of just count through this and you can sort of restrict your inputs to the model. In Palm, unfortunately, we don't have a way for you to calculate, but we have given you a rough calculation so that you can sort of either write a function or do this calculation before sending anything. Um, so that is max input token. So how much is the input that is allowed? There's also max output token, which is what you see here. So the max output token is different. So do remember there's an input and there's an output. There are limitations on both the sense. So input is typically 32K, 8K, 4K, something in that range. The output is how much tokens are you expecting the model to generate. So there also, for example, for 001 model, the limitation is 1024 tokens, which means whatever you're asking, make sure that you're not asking it to sort of generate 100 pages of document, because you can see that 1024 will not give you a 1,000 page document or 100 page document if, let's say, we assume more than average per page. So you can control that. So you can say, hey, I'm not looking for anything more than a page or something. So you reduce the output tokens in that sense. Like, let's take an example. So for example, if you just take max output token value to be 5 and you ask the same question, list 10 ways that generative AI can help improve online shopping experience, you can see that it actually stopped in between because you already said 5 tokens. 5 tokens again doesn't mean words or characters. The mathematics is different. Remember that point very well. But the moment I change it to 500, you can see that it suddenly sort of will start producing more output. And as you can see, it did, right? So that's a different, this is how you can sort of control the length of the output. And that's again very important. Like I said, if you're, for some reason you want to, that's the way for you to sort of do this thing. Okay. What we can also do is, because a lot of time models do send you markdown text. So if you actually see, you can see the stars which are given, which essentially means that you can display this as a markdown. One way you can do is you can use the display markdown in the IPython. The same thing happens. Oops. Let me. I think I'm signed out. Just give me a minute. Okay. Oops. All right. Anyway, so you can actually display this using the markdown function that we have in the IPython, and then you can actually see a very interesting output, right? So this thing now looks bold because we are essentially doing bold there. So you can actually display this properly. So again, always something to remember, that you can actually control this from the instruction. So you can say, hey, I want the output in table format. Then it actually gives you in the table format. You can also say that, hey, I want the output to be in a JSON format, and you can define the JSON structure and it will sort of put everything in that JSON format as well. Then we have the top P, which is the probability or the selection of the tokens, and how you can define that or sort of influence that probability as well. Again, think of it like this. And again, there's a whole nuance and theory behind what this value is. But in a very simple term, if you have to think about, all the LLMs are doing is they're predicting the next token. Again, remember this token is what they predict. They're not predicting words like the way we think about it. So when they're predicting the token, you can actually influence the choice of that by mentioning that, hey, I need all the tokens which should be higher probability. Higher probability means that your outputs will always be very deterministic, real world sounding. If you reduce the probability, then it will give you new words. So you might have not thought about those words. And things like when you say, hey, can you rephrase this whole statement into more creative way, you're essentially saying that reduce the top P to the lower level, because I'm expecting it to give me words and combination of words which are more creative in that sense, right? So this is what top P sort of helps you achieve. This is why, if you notice, the default is 0.95, because you're trying to be very deterministic. You're saying, no, 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 do not select anything which is not going to sound very real or something which is out of the box. Very similarly, and in fact, let's run this. So we're going to run top P0 and top P1. And the question that we are asking is create a marketing campaign for jackets that involves blue elephant and avocados. And if you actually read through this, and I'm going to give you time when you actually run this along later, you'll see a very stark difference between the kind of words which were selected when the top P is high versus the word which are selected when the top P is zero. And you'll clearly understand the difference that okay, when the top P is less, I am being more creative, and I'm sort of loosely using the word creative here. It doesn't mean that creative means right. It may actually randomly say weird things which may or may not hold true in the real world. But because you restrict the top P value to the high, what you start noticing is that it will have a very obvious choice of words. It will not have very weird word or a phrase selection it would do. So again, something to keep in mind. The top K is very similar. Top K is again, imagine that because you have to do the selection of the or the prediction of the next token. Imagine this to be a bucket. From this bucket, you have to select those high probability values. So that bucket from where you need to do that selection is what the top K is. So when you say 40, it means my next token has to be picked from these 40. How do I pick that? That's what you define in the top P. So it's very simple to understand. Again, I'm sort of trying to make it very simple so that we don't go into intricacies of probabilities and all of that, but in a very simple sort of visual way you can think that okay, every time I have to do a token prediction, how much choice do I have? Should I have just 10 tokens or 40 tokens, or one token or 40 token is the first thing that I can select among those choices. Let's say I do select 40, then among those choices, which one should I end up selecting is what's defined by top P. So these are two very sort of closely related values. Each one of it has an effect on the other. So if you reduce top 40 to, let's say, um, just 10 or 1 or 5, and you keep playing with the top P value, you'll have a very different result coming out of it. So let's say we do write a 2-day itinerary to France. In this, you can see I'm just selecting top K1, which means you'll see again a very deterministic kind of output because you're not sort of letting it choose from many other combinations and possibilities. But the moment you do top K40, you're sort of trying to make it sort of choose from many things. So which means your outputs will look better if you're trying to look for more creative things. And again, you can sort of go through each and every output, and you'll sort of get the sense and feeling of how they are making this effect. All right, with that, let's see the chat model. So we have seen the text model. How do you pass all the parameters in the text model? How do you send the prompt? How do you make it dynamic? You also saw that how those parameters, when sort of playing with the value or control knobs, you can sort of affect the outputs as well. And we also saw how in the prompt you can mention certain instructions, and that instruction, along with the parameters, will have effect in the outputs that are coming out. So it's not just a single window where you write something and you always get something. And you might think that because you might have explored Bard and ChatGPT and all of that, where you don't get all of this control. So you see a very stark difference between something like a chatbot versus something like an API where you have so much control of things, right? And I'm not saying having a control is a good thing, but having a control is an important choice that we should have. So one thing that we can do is the next thing that we'll cover is the chat bison thing. So the chat bison is, like I said, what we are essentially doing from a the chat perspective. So we saw the text. Now we are seeing how do we do the conversation. So again, the model is tuned to do conversation. So that's why you see the difference in the naming as well. So text bison is tuned for one turn conversation where you send something and you get something out and you stop. You don't sort of expect it to remember anything. Chat bison is a model where it is tuned in a way where it can remember the context. It keeps the conversation in a conversational flow. So the way to do this from a code perspective is first is again you do something same as text bison, which is you initialize the model from pre-train and you call this as chat bison 001, and you change the version 002 or anything that you feel to. One thing which you'll see here, which is slightly different, is the fact that the chat model also sort of has a session. So the moment you initiate this session, this is where you're sort of saying that, hey, I want to initiate the session of this chat, is important. And we'll see why this is important, is because the moment you are inside this, it will remember the context of everything that you're asking. So let's take an example. I'm going to send the first message to it. I'm going to say, hello, can you write a 300-word abstract for a research paper? And I'm going to hit enter. So you can see that I have now established a new session. In that session, I've sent the first message, of which it has given me the response. So you can see it has written a huge abstract paper. Now, the second message that I'm going to send, you can very clearly notice that I'm not putting any context. I'm just like a normal chat. I'm saying, hey, can you give me catchy title for the paper? And this is the difference between the text and the chat, because the text one, you couldn't have done this unless you would have manually passed the previous prompt and the response in the new prompt. Here, you don't have to do anything manually because it remembers that context very easily. So you can say, can you give me catchy title for the paper? So it knows that which paper I am talking about and what did I ask before and what was the response to it. So the moment I hit enter, you can see that it actually blocked. So this is good. So what is happening now is that you can actually see that there are some things which are coming out which are sort of seems to be blocked. So it might have produced something where it shouldn't have produced. So you can actually see there are some links which it has came up with, and these links are something which it is sort of trying to block. And like I said, all of these things essentially returns not just text, but a lot of different attributes through which you can control this. So this doesn't mean that you will never get the output if Google decides to block it. It means that you get the control on you, that you can define those controls, saying, hey, never block anything or slightly block if they are greater than a probability or something like that. So then if you move further with it, the other thing that you can do is you can actually define the examples and the context. So context is again very similar to like putting a system prompt. So you're saying, hey, context is my name is Ned, you're my personal assistant, my favorite movies are Lord of the Rings and Hobbit. And then you also define how the conversation or the behavior of that conversation should go like. Do you want the chat interface to talk too much, or do you want the chat interface to always respond very in a very short manner and things like that? So if I hit enter, and again, sort of, I think it's picking up. So what did I ask is a very simple thing. I'm asking, I'm sending sort of two of the examples, and I'm setting the context. And in the context, if you notice, I am already giving it some information saying my favorite movie is A Lord of the Rings and Hobbit. I'm giving this as a context, right? Then I'm asking the question, are my favorite movies based on the book series, right? So if you see the output, you can see towards the very end, there is a candidate equals to yes, they are. So this is the answer. And, you can sort of extract that. But this is very good for you to see that it sort of gives you safety ratings. It is also telling you the probability and the severity score of each and every output. So you do have control of all of those things. The actual text essentially comes towards the end, which is the candidate equals to yes, they are. So you asked a question, and that question has to be answered. So it's so that you reduce the hallucination. You're passing that context as of now, and it sort of gives you that yes, they are. So this is not hallucinating. Why? Because you've given the context in that sense. We can ask a follow-up question. We can say, we can ask that, hey, when were these books published? So again, if you see the last one, the candidate one, it says Lord of the Rings was published in 1954. The Hobbit was published in 1937, right? So this is the part where you can sort of explore much of these things in a much easier way. And this is where you can build the both the chat and the text part of things, right? The parameter space remains the same. There is no difference, at least in the parameters. So, for example, you will notice when you're initializing the session or the start chat session, these are all the things that you can pass. So, first is the context, second is the example, if you want to sort of control the behavior of it, and then the parameters that you have, and same parameters that we saw in the text. All right. So the next thing that we want to cover is, and now we are towards the very end of the whole thing. The next two things that I want to show you is how do you do embeddings. So embeddings in a very simple way. Again, there's a whole lot of theory that goes behind it. But what we have is we have an embedding model. What embedding essentially does is, imagine this to be like when humans say something in a particular language with which the other human understands. One thing which is very interesting is that we get what the other person is saying, and a lot has to do with the fact that we understand language, right? But we never really question that how do we understand the language. So I'm speaking something, and all of you are able to sort of comprehend and understand what I'm saying. That's very hard for computers to do, right? Because computers are not built that way. So one thing that we do in that direction, and this sort of starts from word to vector and things like that, but one of the very interesting thing that we do there is that we have models which can understand the semantic behavior of your text. What I mean by semantic behavior is that it understands the semantics of what you have written. So when you say what is life, it understands in a very similar way how a human would understand or interpret this. It's not exactly same, but it's pretty much in a way where it extracts the information of the text, encodes that information, and gives you those numbers. Now these numbers will not make sense to you for sure. Like no human can sort of see this and say, oh, I know what it means. But they're great to computers, and they're also great when you want to compare two paragraphs or two strings, or let's say two text. So if you, let's say, one of the examples that we have shown here, let me sort of run this, and you can see it's a huge text that comes, right? So let's say I have bunch of different text like this. I really enjoyed this, so many amazing cinematic scenes. So you can imagine that we have these five sort of five sentences. The goal is I want to understand how similar are these sentences to each other. So what I do is I basically run each sentence through an embedding. So I get the numbers. So the left side is what humans can understand. And we can all figure out which sentences are close and which are sort of completely opposite of each other. But to make this understand to the computers, we sort of have these numbers. Once we have these numbers, we can do something like cosine similarity. And again, you can read about what cosine similarity is, but it's like a vector dot product where it sort of tries to find the cosine theta. But whatever that is, the magic is you get a number between 0 and 1. And very simply, you can say if the number is closer to 1, it is essentially very similar. If the number is closer to 0, it is essentially not similar. One thing to note here is similar doesn't mean same in terms of semantics. So it may be actually talking negation of each other. It might be saying that I hate A and I love A. So you can imagine from a contextual point that both of them are sort of different. But semantically, they are same because they're talking about the quantity A or the person A, right? So that's why this is what we mean when we say semantic similarity. So if you see this example, it says so many amazing cinematic scenes yesterday, and then the other with which it has shown you 71% similar, 71, not 71%, my bad. 0.71 similarity is this sentence, which is I really enjoyed the movie last night. So this is very fascinating if you think about it, because it somehow understand that cinematic scenes and movie last night seems to be talking about somewhat similar themes. It's not exactly same themes, but it is somewhat like almost zero point 0.7 closer to 1 in that sense, right? Let's take another example. If you see this 0.73, you will see that the sentences which are seeming to be close to each other is had a great time writing my Python script a few days ago. And then this is huge sense of relief when my .py script finally ran without error. Again, very interesting. This is the kind of intelligence we need, right? Because it again understood that writing Python and writing .py is essentially somewhat similar theme. Again, it's not one, but it's very high number. 0.73 is good enough in that sense. So that's the kind of things you can do with sort of embedding. So once you have that, it enables you to do a lot of things, and some of those things we have listed down in the markdown as well. So let me sort of go quickly up. Is you can do semantic search, you can do recommendation. So let's say kind of text that you have, you can find similar text, you can find similar recommendation of those texts. You can do classification, clustering, finding out the outliers in the data. So there's a lot you can do because now you're able to encode the semantic meaning or expressions of the text in a very beautiful way. This is not one embedding. There are many embeddings. There are open source embedding. There are closed source embedding. There are hosted embeddings. The one that we are using is Palm embedding, which is again hosted. It's not open source. You can't download it. You have to make a simple REST call to get these numbers out. So now I'm going to show you the last thing, and then we'll stop. Is doing the same all that we have seen. So we have seen text, we have seen chat, we have seen embeddings. The last one is the code generation. So everything remains same, nothing changes. You're still loading everything from pre-trained, and then you are calling a model code bison 001. Same thing, you can change it to 002, you can change it to 2K. You know the names of the model, you can see that in the UI as well. It also has pretty much same parameters minus except some parameters, for example prefix. So prefix is essentially, let's say you want to start with hash python or hash html, or let's say json or something. There's something you want to start with, you can actually define that as a prefix to control the generation. So you can actually pass, let's say, the name of the function and say, hey, start doing what I'm asking you to do, but here's the starting function that you need to keep in mind. Everything remains same. So you still have a prefix. Oops, I didn't run this. So let me run this, and then I'm going to hit this. So my prefix here is write a Python function, which again acts like a prompt. So there's nothing new, but it sort of acts like a prompt. Is a write a Python function to do a binary search, and again sort of goes into detail and gives you the whole Python function. Again, you can actually experiment this. You put the same prompt in the text bison. There also it sort of gives you a function. But like I said, this model is more optimized for the code, so it'll be easier for you to sort of use code generation for a specific one. You can go more in detail. You can sort of say write a Python function named as calculate cosine similarity. That's the example I was giving. Like you can give a prefix and saying, hey, the function name should be this. And 3 unit tests where it takes two arguments, vector one and vector two, then uses numpy dot function to calculate the dot product of two vectors. So you can see that you can get too specific to your requirements, saying, hey, this is the kind of things that I'm trying to do. So if I run this, you can see that it'll sort of go through each and every instructions. It gives me the same name of the function, including the variable name. And then it also sort of gave me the unit test of all of those. So this is interesting. Like this is more than what we could have imagined, right? And the same thing, sort of the same prompt template idea that we saw in the prompt also applies to the prefix. You can sort of write a very general template saying you choose your language, you choose the file format, you choose what is that you're trying to extract. So this one is essentially where you sort of delete, sort of put everything in a separate variables. So the requirement is this. This is what you're looking to extract from that requirement. The format of the file is going to be JSON, and which language do you need is C. So we support, I think, over 38 languages as of now. By languages, I mean Java, C++, HTML, Python, Swift. There's many that we support, and I'll show you where you can sort of explore more and find about that more. But all of them are available in the documentation, so you can get the details from there as well. Code model has three layers. So one is the code generation, which we just saw. The second is code completion. Code completion is just like, think of IDE, any IDE that you use, either VS Code or Google Colab. You know that when you type, it sort of gives you what is next, right? If you want to build something like that with your own data in the environment where nobody is taking your data to training, code gecko or the code completion model is the model that would be very helpful to you. So this doesn't give you whole generation, it only gives you the next few tokens. So if you run this, you will notice that, oops, let me run this. So you will notice that it doesn't sort of give you the whole thing. And this is not to write a prompt as in like, oh, give me this, that. This is very similar to making sure that you're writing something and then it gives you the next completion for it. So this is just very specific to the completion, not to the generation. And the final one is the chat one. So chat again works exactly same as the text. It's just that this time you're trying to do more code specific things. So again, it gives you back And if you see the candidate, it shows you here's the function that calculates the minimum two number. I'm going to quickly run this. So one of the very interesting things that you will notice here is that we start by saying, please help write a function to calculate this. And then the next text that we are sending is, can you explain the code line by line? So you can imagine that it's storing all those contexts with it, right? That's how it is able to tell me exactly line by line what it was generating and then explain me exactly the same thing. And that's all from my end. I think I'm 1 minute delayed. Just one last thing, and then I'm going to stop. Is that in the same language folder, you have something called as prompts. If you want to explore more real world cases from a business perspective, you can actually see all of those prompts here and you can play with this. I would highly request all of you, now that you have access to the lab for some days, go and run all of these notebooks, and this will be really helpful to you to explore what else can you do. We have done L100, like very basic. When you go and do this on your own, explore all the notebooks, you'll be able to sort of do a lot of things, right? With that, I'm going to stop, and let's bring Prashant back and then we'll address questions. Okay. All right. So I have some questions here. I think some of the questions are already addressed by my colleagues here. So the first is, how is top P different from the temperature? Okay, very good question. That's a very interesting question because one of the things is people get to a point where they sort of, hey Prashant, so I'll take the first one. I think it's tagged to me, is that temperature sort of helps you control the overall randomness. Top P is something which is more granular. So it's between the choice of those tokens. But you can imagine that if you don't want to go granular control, you just control the temperature and you don't go sort of granular with top P and top K. So that's the difference. So the overall effect is going to be in the same direction, but the knobs are different, and top P will sort of help you control this more granularly if you're sort of trying to be very specific to the kind of word choices and all of that. I hope that helps. Second question is for, again, me. Is it possible to do LLM on structured data in BigQuery, like sales data? Yes. It is possible through two interfaces. One is BigQuery already has a connections with LLM. So BQML can connect to text, Python, and also you can do all of those things there. And it can sort of help you generate the BigQuery SQL and all of those values. The second is Vertex models are connected to LangChain. So I'm assuming you know what LangChain is. So you can explore the connections, and there you can sort of do the same thing with the structured data. Prashant, next question is on you.
Sure. So the question which I'm taking is, what's the difference between the various versions of Gemini, and which one can be accessed now? So, like I mentioned in my presentation, there are three versions being planned. The topmost is the Ultra, which is not yet available. It would be soon open for private preview to customers. You can think of it as, the largest model, most capable one of the multimodal capabilities. The second one would be Gemini Pro, which is open. Lavi showed you that. It's available within the Vertex AI console, so you can start playing around with that right away. And the smallest one would be the Nano, mostly designed for the wearable devices and mobile phones, things which have less memory. I think it may be tuned on around the range of 1.5 to 3.5 billion parameters. So that particular model would be um, available on these devices and may not have all the multimodal capabilities. It would have limited capabilities. Second question which I have is, what is model garden, and what benefit do I get out of it? So it's think of it as a library of all pre-trained models available to you. You don't have to create anything from scratch. Just deploy those models and start using it. So it's a one single shop stop available to you to use any of those pre-trained models, and those models can be from Google. Those could be open source third party models. uh, The benefits which it provides is, first of all, the availability part of it. Everything is available to you. I think 130 plus models are available as of today. Really saves you time. You don't have to search, import, and do all those things. It's already available within the console. So it's the time to market which you get out of it. And these are already verified and then made available to you in form of model garden, plus all the integration surrounding let's say the notebooks, managed notebooks and other things which you can use to consume these models. So it's a one single ecosystem which you get, rather than hosting these models on a VM and then doing everything from scratch. uh, Another question which we have here is, we heard about Duet AI. Can you please double click on that? Okay, so Duet AI is actually, you can think of it as a artificial intelligent collaborator available to you in multiple forms. So it can do various things. For example, we have Duet AI for workspace. So in within Google Workspace, you have you know services like documents, slides, sheets, and the meeting console, Google Meets, right? So this Duet AI for Workspace can actually help you across all these services in writing your docs, in summarizing data, in creating charts out of Excel sheets, your sheets, in creating images out of your slides, helping you, reword, rephrase the context and so on. Whatever a LLM can do, you can actually utilize those capabilities within these services. Then we have Duet AI for Google Cloud, which you can actually use to understand Google Cloud better. Best practices around, let's say, BigQuery, Dataproc, creating your instances, optimizing your services, your understanding your bills and logs, and all sort of things you can do. And then we have Duet AI for developers, which you can actually use to generate code, write test cases around it, uh, complete the code. Generally, when somebody moves out and they have a code which they have written, it becomes really difficult to understand that code. So you can just Duet AI can really help you understand that code very fast. Lovey, back to you.
Um, the next, oh, what is the difference between Palm 2 and Bison Gecko model? Is Palm powering them? Is Gemini okay, let's address the first part. So Palm 2 is family of models. There are many different models, and like Prashant was saying that there are different sizes of the model. So those are the sizes. Rather than saying billion models, we actually have names for it. So the Gecko is essentially the smaller. The Bison is then the next, and then we have Unicorn. Unicorn is also something that we recently GA. So we have different layers in terms of the size of these models. They're all part of the Palm family. They're not different models. It's just that they are different sort of sizes, which means their capabilities are also different. So it's not like Unicorn is exactly same as this. They all are built differently to address certain specific things. So Gecko is the smallest one, which means you can sort of have a very fast latency. They are sort of small, so their size in terms of the cost that you will incur to call them will be less. But of course, you lose the accuracies and sort of effectiveness of it. And then the unicorn being at the top layer in that sense. The second part of the question is Gemini comparable to Palm or Code Chat model? So again, first thing is, like I said, Gemini is a separate family, Palm is a separate family. They are both different in terms of Gemini is multimodal. You can say Gemini Pro versus the text Bison model. So they are very comparable. And you can sort of play with this to see this difference. But like I said, Gemini family is very different because they're multimodal. They can take images, videos, and give you answers in text, which you cannot do with the Palm models. Palm models are by default code and text, and Gemini models, especially your Gemini Pro Vision models, are essentially multimodal as of now, which accepts image, text, and video, and can only produce output in text. And later we'll add more modalities in that sense. I hope that answers.
I think there is one more question. Can visualization plots be interpreted from data by LLMs for automating visualization tools like that? Yes, that's a use case which can be implemented using LLMs as well.
In fact, you guys can go and check the repo that I was showing you. We actually have shown this example using Gemini.
Okay, cool. If there are no more questions, then I think we can close this. And I really thank you all the audience, for joining us today. Hope it was a session which you really enjoyed. And thanks for all the interesting questions which you have posted. And the recordings of this session, there were many questions around recordings being available, and lab links and so on would be made available by next week. Lab links would be resent to you, so you can give it a try again. And if there are any further queries related to usability of these services, please feel free to reach out to your Google account representatives. And thank you all.
Thank you all. Have a great day.